Assalamu alaikum. I hope you are finding this video helpful as you prepare for your exams. Understanding direct and inverse proportionality is crucial, and I have made sure to cover everything you need to know in this full course. So please subscribe. And welcome to everyone who has come to this channel to learn something. And today our topic is about other forms or advanced forms of direct proportion. What we have learned so far is just like in simple terms. Let's say we have two variables, that is x and y, and when they are directly proportional to each other, we say that y increases or decreases, x changes in such a way that the ratio y by x remains constant. And to this constant we represent it by k usually. So when this is the relation y by x is equal to constant, then we would say that y and x are directly proportional to each other. Now it's time to discuss some other forms of direct proportionality. Consider these two variables again, and they are now this time they are connecting by some other equation. Let's say y is equal to 3 times x squared. And to prove this thing or to know, I will take some values of x and the corresponding values of y and y by x in a table. So let me show you simple table. This is the table where this row belongs to x, this row belongs to y for this equation, and this row belongs to y by x, where when we substitute x is equal to 1 into this equation, it will return us 3, and when we substitute 2 into this equation, it will return us 12, and similarly for 3 it will result 27, and for 4 it will generate us 48. And this rows is actually when y divided by x will get us these values. So when 3 is divided by 1, it will give us 3. When 12 is divided by 2, it will result us 6, and when 27 is divided by 3, it will result us 9, and similarly 48 divided by 4 will give us 12. Now we will see its graph. So to show you its graph, and from their result we will conclude that whether it is direct proportions or not. Now you can see that this shows the graph of y against x for this table. And one question, is y directly proportional to x? Let us explain our answer using this graph features. Now the graph of y is equal to 3x squared. It is a parabola that opens upward. The curve is symmetric around the y-axis. It is typical shape of the quadratic function. It does not form a straight line, hence it does not represent direct proportionality. As x increases, y increases at a faster rate because of x squared. The graph does pass through the origin, we can see here, but this alone is not sufficient to prove direct proportionality. Hence the relationship is quadratic, not linear. So in the conclusion, in this equation, y is equal to 3 times x squared is not directly proportional to y. So we come to know about this thing. Now again, we have using this same the earlier knowledge to know about this one. I would do another job just by showing you another values or a table, some values of x and corresponding values of x squared, y, and y by x squared. Now this is another table. We have also substitute that same values, but here I have plugged in another row or added another row of x squared. So you can see this will give us these results for this equation. Now if I draw its graph, then I will see that what does it give us. Now this is the graph of y against x squared, not x. I repeat that I have drawn graph of this for y and between this x squared, not only x. In previous table there was the graph for x and y. In this previous table, if you see, we have plot graph between x and y, and this was additional. row. But here in this table, we are drawing graph between x squared, this for this row and for this row. Okay, so it's the graph of y against x squared, and you will see that this graph of y against x squared shows a straight line passing through the origin. This indicates that y is directly proportional to x squared. In other words, as x increases, y also increases linearly, and their ratio remains constant. And we can see this in this table that as this x squared increases, y also increases, and their ratio y by x squared remains constant, which can be applied on this rule. So as I told you, so this is why y is directly proportional. For this, I can say that y is directly proportional to x squared, but not directly proportional to x. Okay, I repeat, y is directly proportional to x squared, and that the earlier table we see that ratio y by x wasn't constant. Let me show you that row again. So look at this, y by x, it's not constant, it's keep on increasing. So there is a variation in this row, but for y divided by x squared, it's constant, there is no variation. So this knowledge can be applied on this. So I can easily conclude that y is directly proportional to x squared, and it is not directly proportional to x. So I can say that y is directly proportional to x. So it is wrong. They are not directly proportional, but here you can see a by k. So yes, y by x squared is equal to constant, which is k in this case. So this is yes. So this is wrong. They are not, but here it is true. Now another way to look at this thing is to let x squared is equal to capital X. If I write this one as y is equal to 3 and this small x squared is equal to capital X, then I can write it as y by x. Capital X is equal to 3. So therefore y is directly proportional to capital X, which is originally equal to small x squared. So I hope this may have make a sense. Remember, every subscription counts and motivates me to keep bringing you the best educational content. So hit that subscribe button and let's conquer these exams together. Let me take an example that whether when I have to identify variables which are directly proportional to each other for this equation of x and y when they are connected to each other by y is equal to 5 times x cube. We came to know about this thing, and remember that this is capital X when this x was originally equal to this x squared. So to make it like that way, I can also make it so simple that y divided by x cube, because I want to isolate this 5 or want to have a constant number on one side of equality to fulfill this condition or this one. Okay, so this will cancel with each other, and here we have got y by x cube is equal to 5. So this is a constant, and here I can easily replace this 5 with k. So this, when this happens, then I would say that y is directly proportional to x cube and y is not directly proportional to x. I hope this may have make sense to you. Now please subscribe to this channel and also share this contents with your friends and colleagues. Thank you. Good luck with your studies, and don't forget to check out the full course on direct and inverse proportionality and the playlist. You have got this.